This is question 25 from section B of the 2018 PBSAA paper. In this question, we're given a line and told it passes through the points P, P minus 1, and 1 minus P, 2P, where P is some parameter. And we're told the line is parallel to this line given by this equation, 2x plus 3y plus 1 equals 0. And what we're asked to do is find P. So how do we go about this? Well, look at the key information. So we've got these two lines, and the only thing we know that relate them is this, parallel. So what does that mean? Well, that means this. It means that the gradients of these two lines are equal. So if we can work out the two gradients, equate them, we might be able to find some stuff out, right? So let's do this one first. 2x plus 3y plus 1 equals 0. How do we get anywhere from this? Well, this isn't particularly nice in a minute, but we know that if we have a line in this form, y equals mx plus c, then m gives the gradient, doesn't it? So if we can get this to a form looking like this, we're sorted. We can just read it off. And indeed we can. So we want y on its own on one side. So let's get rid of the 2x and the 1. So we get this here. And then we've got 3y, so why not divide through by 3? And we've got this, and from here, this is great, because we can just read off the gradient here. So our next logical step is to find the gradient of this other line. We've got this one's minus 2/3, what's this one? Well, we don't quite know what a line looks like, but drawing a diagram will be helpful nonetheless. And let's put point 1 minus p, 2p up here, and p minus 1 down here. It doesn't really matter which way we put these, but it just helps us be consistent and makes working a gradient out simpler. So we want to work out the change in y over the change in x. So change in y will be 2p minus p minus 1, which gets to p plus 1, and similarly 1 minus p, which gives 1 minus 2p. And note the thing that mattered here was always starting with this minus this and never swapping the order. So we didn't do this minus this over this minus this, because that would mess it up. We've got to be consistent. So this is why we drew the diagram. But we've got a change in y over the change in x. And so we know my gradient is this, p plus 1 over 1 minus 2p. So we've got both the gradients of these, and we're almost there. So we've got our two gradients. And the final thing that remains is to equate them, because we know they're equal because they're parallel. So let's do that. So algebraically we get this, and we've got to find p, so all we've got to do is rearrange this to get p, which is a little bit of a pain, but let's start with this. Let's just get rid of this minus sign. I'm not a big fan of it. So times 3 by minus 1 here, times 3 by minus 1 here, and it just flips 1 minus 2p to 2p minus 1, and I think this is just easier to deal with. Now, next step in thinking, I'd rather not deal with fractions, so let's times through by 3 times 2p minus 1. So the 2p minus 1 disappears here, but we get times by 3 in the numerator, and similarly 2 times 2p minus 1, because the 3 cancels with this. So let's expand these brackets, and we see if we minus 3p from here, we get p, add 2 to this side, and we get p equals 5, which is excellent, because that is one of the answers given in the options for the multiple choice, and it's actually H, so our answer is H.